Hello and welcome to Physics 101 with your favorite white man, Isaac Newton. Just kidding, it's Jennifer. Now today I'll be going over a super interesting topic, which is forces in motion. So forces in motion has a couple of really basic terms that I will just be defining. Now the first term is density. Density is mass per unit volume, or how compact a substance is. Density plays a huge role in the rest of the entire concept of physics, so it's important that we remember that for later. Another really important term that will show up in all of physics, and especially forces in motion, is force. Now, what is a force? A force is a push or pull upon an object resulting from the object's interaction with another object. For example, a push or a pull is a force. So here I am knocking over a bowling pin with a tiny little bowling ball, and that is a push. Part of forces in motion is the really important concept of Newton's 3 laws of motion. So let's get right into it. Newton's first law states that an object at rest stays at rest, and an object in motion stays in motion with the same speed and in the same direction unless acted upon by an unbalanced force. Before I spin this fidget spinner, it was still, so it was at rest, and while I'm spinning it, it's in motion. Once I place my finger on it, it stops being in motion. This shows the first law of motion. An example of Newton's first law in action is called inertia. Inertia is related to the amount of force needed to make an object move or change its motion. In other words, objects tend to keep doing what they're doing unless they're acted upon by this unbalanced force. An example of inertia is when you're riding a skateboard and you fly off the board, when you hit a curb or a rock or another object that abruptly halts your motion of the skateboard. Now notice as your skateboard is halted by this rock, you keep going forward, and therefore you kind of just fly off the skateboard. I'm going to hatch an excellent plan. How about I demonstrate Newton's first law on something extravagant? The egg was not in motion, and then it became in motion to fall towards the center of the earth when I knocked over the toilet roll. The second law shows that if you exert the same force on two objects of different masses, acceleration on the smaller mass will be greater than the effect on the object with the larger mass. Simply put, this law can be shown through the equation force equals mass times acceleration. So for example, if I exert 10 newtons of force on this little teddy bear, the effect would be much greater than if I exerted the same force on this giant teddy bear. The difference in effect, or acceleration, is because of their difference in masses. Newton's third law states that for every force, there's an equal and opposite force, or reaction. Here's an example of Newton's third law. So pretend you're riding on a school bus and a firefly just comes out from nowhere and splatters all over your window. Now, both of the school bus and the firefly have applied some sort of force. So which one is greater? Both are actually equal. According to Newton's third law, every action will have an equal and opposite reaction. So to demonstrate Newton's third law, we'll be making a hoverboard. No, not that kind of hoverboard. We'll be making a homemade hoverboard. So some materials you're going to need is a balloon, a CD, and a bottle cap. And you can see in this clip, I am just putting the balloon over the bottle cap so that it can float later on. So a hovercraft works by forcing air out beneath it, creating a cushion of air to float on. The balloon acts as a pressurized gas chamber. So when you untwist the balloon, the air comes out through the cap, creating a thin cushion of air beneath the CD. Now, as we have all seen today, physics is actually a super cool concept, and also especially the idea of forces in motion. We saw this through Newton's 3 laws of motion and also by defining some basic terms such as force and density. I hope you've enjoyed your time today, and I hope you're not too disappointed that Isaac Newton is not here in the flesh.